Welcome sa Logic Design Digital Computer Circuit. So we just finished midterms and the first part ng pre-finals natin. Natapos na natin, multiplexer. Okay, so we'll go with sequential circuits. Okay, so medyo technical to, so discussing ko lang yung yung mga basic parts na yung mga definition lang and some significant parts ng discussion. Okay, so we go with sequential circuit and our learning outcomes is to define sequential circuit, know the different types of sequential circuit, understand clock and its classification, and know about flip-flop latches. Introduction: in the previous session, we said that the output of combinational wala pala ito yung ko. Lipat tayo ng sa books. Yan, dito. Yan. So, meron ng mga naka-highlight na yung Okay. So, under ng sa introduction, the implication is that combination circuits, so difference ng combinational circuits sa sequential circuit. Itong nauna have no memory, no? Combinational circuits have no memory, while yung sequential circuit merong version na walang memory pero pwede siyang lagyan ng memory. Okay? So in order to for a device to serve as a memory, it must have two stable states, way to read the state and a way to reset or set the state, no? So a very important feature ng sequential circuit is the concept of feedback, no? So far the logical flow of the circuits we studied has been from input to output. Pag sinabi mo ng feedback, then it will be output is fed back to the input, no? So yung input to output, it is called a cyclic circuit. Okay? While the output, if the output is fed back to the input, it is called a memory or circuit memory. So this is the yan, kaya hindi ko nilagyan ng overlay na cam, ay may mga kasi may mga diagram and figures, no? So para makita nyo lalo, mas malinaw. Ayan, mas maraming space, no? So meron ditong inputs. Ito yung ating conventional na circuit, no? Combinational. Ito yung outputs niya. Kapag nilagyan natin siya ng memory, yan, the output is fed back as input, no? Then it will be a sequential circuit. Okay? Next, latches and flip-flops. Okay? So, latches and flip-flops are the building blocks of sequential circuits. While gates have to be built directly from transistor, latches can be built from gates and flip-flops can be built from latches. So, from latches we can build flip-flops, and from gates we can build latches, no? And the gates are built directly from transistors. Okay? So, yun ang kanilang hierarchy, no, ng mga parts. Okay? Both latches and flip-flops are circuit elements whose output depends not only on the current inputs but also on previous inputs and outputs. The difference between the latch and the flip-flop is that sa flip-flop meron tayong clock signal, sa latches ay wala, no? So we go now with latches. How can we make a circuit out of gates that is not combinatorial or that is sequential? No, the answer is feedback, which means that we create loops in the circuit diagram so that output values depend indirectly on themselves. If such feedback is positive, then the circuit tends to be stable states, and if it is negative, the circuit will tend to be oscillated or tend to oscillate. O, ibig sabihin, magiging unstable ang outputs. Okay? So the circuit shown below is a NAND latch. The inputs are generally designated SR for a set and reset. Okay, so we go now with the figure, no? So ito yung ating latch. Okay? So we have this set as complementary. Ito yung NAND latch to, no? NAND latch. Okay? So ito yung complementary ni set, complementary ni reset. Okay? So remember sa discrete structures 1, pinag-aralan natin na yung guhit na yon, that means complementary or kabaliktaran. Okay? So yung input dito ini-invert natin. So meron ditong converter or inverter, okay, yung ating NOT gate, yan. And then this represents the output and the complementary of the output, Q, no? So anong meron sa NAND latch? So changing, and for the NAND latch circuit, both inputs should normally be at a logic 1 level. Changing an input to 0 level will force that output to a logic 1. Okay? So kung ito daw ay magiging 0 pareho natin ipapasok, ito daw ay ma-force na magiging 1, no? Kasi meron siyang inverter dun sa dulo. So kapag daw note that it is forbidden to have both inputs at the logic 0 level at the same time, the state will force both outputs to a logic 1, no? So bakit hindi pwede? Kasi nakita nyo, ito ay si Q complementary ni nung isang output. Pag sinabing complementary, kung ito ay 1, dapat ito ay 0. Kung ito ay 0, dapat ito ay 1. So kung magiging 1 sila pareho, that would force, no, the device, no, to hang or to shut down. Okay? So that is for the NAND latch. Ito naman yung sa NOR latch. Okay? So for the NOR latch circuit, both inputs should normally be at a logic 0 level. Changing an input to a logic 1 level will force that output to a logic 0. Okay? So baliktad naman sa NOR, no? NOR latch circuit. Dapat ito ay, makita nyo hindi na siya complementary, no? So dapat siya ay 0. Okay? Para hindi siya ma-force na maging output sa 1. Okay? So yun ang difference ng NAND latch sa NOR latch. We go now with flip-flops. Latches are asynchronous, which means that the output changes very soon after the input changes, no? Outputs of a sequential circuit change simultaneously to the rhythm of global clock signal. Okay? So yun yung sinasabing asynchronous. Sa asynchronous ay the output changes very soon after the input changes. Pero sa synchronous, the output depends on the rhythm of the global clock signal. So this is the representation of the flip-flop circuit, no? So it can be constructed from 2 NAND gates, ito yung 2 NAND gates natin, or 2 NOR gates. Dito muna tayo sa NAND gates, no? So yung basic idea dito is when Q is 1 and Q is 0, it is in the set state. Ibig sabihin ng set ay nilalagay niya sa memory yung value nung previous state niya, no? Pero kapag 0 and 1, binubura niya yung clear state. Binubura niya yung laman ng or yung previous value nung memory. Okay? So when a 1 is applied to both the set and reset inputs of the flip-flop in figure 2, both Q and the complementary of Q outputs go to 0. This condition violates the fact that both outputs are complements of each other. So hindi siya pwedeng maging 0. Okay? Parehong 0. Dapat kung ito ay 0, 1 siya. Kung ito ay 1, dapat ito ay 0. Okay? So ito na, nakita natin yung dito yung truth table, no, ng flip-flops under ng NOR gates. Okay? Ito NAND gates pala to. So ito yung NOR gates, no. So nakikita nyo dito, hindi dapat siya maging 1-1 kasi ma-force siyang maging 0-0 ang kanyang output. Okay? Sa NAND gates naman, Sa NAND gates naman, hindi siya pwedeng maging tagawan ba to? Yan. Okay? Yun yung sa NAND gates. Okay? Yung sa NOR gates naman is ito yun. Okay? When the both inputs go to 0, both outputs go to 1. So, hindi dapat siya maging 0. Okay? Ayan, 0. Then, magiging siyang 1, 1. Okay? So, yun ang difference ng NAND gates sa NOR gates na flip-flop. Okay? We have another type of flip-flop, the clock SR flip-flop. Now, the clock SR flip-flop shown figure consists of basic NOR flip-flop and two AND gates, no? So ito yung ating AND gates, ito yung ating NOR, yung inverter natin, NOR gates. And then sabi dito kung ito daw ay 0, okay? Kahit ano pang value nito hindi maapektuhan ang output, no? Basta ito ay 0, yung 0 yung clock pulse niya, yung output natin ay magiging parehong 0, okay? And yan ay nag-iiba depende dito sa pulse ng clock, no? So makikita natin dito is ito yung meaning nito, yung next state, no? At narito yung ating output. Okay? So ibig sabihin ng next state nung yung isa, no? Kung ito ay 0, yung complementary, ito yung next state, magbabago yon depende dito sa clock pulse. Okay? So split seconds lang yung kanyang pagiging 0 kasi itong isa ay will be immediately changed depending on the pulse, okay? Dun sa clock. Next we have the D flip-flop. The D flip-flop is a modification of the clock SR flip-flop, no? So meron kasing instability yung SR flip-flop, no? So yung dinevelop nila yung mas stable na flip-flop, no, na version ng SR. Okay? So the same, no, pinagsama lang nila sa isang wire yung reset at yung set na signal, input signal, no. But makikita nyo rito, ito yung next state, ito yung original state niya, yung isang output. Okay? So ito yung hindi dapat nating gamitin, no, yung 0, 0. So pag pareho sila nag-0, ibig sabihin yung next state niya ay magiging 0. So that would violate again yung kanilang complementary state. Okay. Next we have the JK flip-flop. It is a refinement of the SR flip-flop in that indeterminate state of the SR is defined in the JK type. Okay? So when the logic inputs are applied to both J and K simultaneously, the flip-flop switches to its complement state. Q1, it switches to 2, Q0, and vice versa. So nagpapalit sila kahit na pareho nating, kasi kanina dun sa normal, sa ordinary na SR flip-flop, no? Kapag pareho siyang 1, nagkakaroon dito ng unstable na state, no? Kasi nagiging pareho silang 0. But sa version ng JK, kahit parehong 1 to, yan, ang output niya ay magiging 1 and 0 kasi meron siyang added na input dito na connection. Okay? Next, we have the T flip-flop, no? Flip-flop is a single input version of the J flip-flop. So, ginawa lang single version, yung single wire, no? Yung nagke-carry ng input, no? So, itong dalawa is nagtatoggle, no? So, the T flip-flop toggles with this clock pulse. So, pag nagbago yung clock pulse, magbabago rin si input. Okay? Triggering of flip-flops. Paano nati-trigger ng clock, no? Yung state, no, ng input niya. Okay? So the state of the flip-flop is changed by a momentary change in the input signal. This change is called the trigger, and the transition it causes is said to trigger the flip-flop. No? The basic sequence of figure 2 and figure 3 require an input trigger defined by a change in signal level. No? This level must be returned to its initial level before a second trigger is applied. No? while clock flip-flops are triggered by pulses. Ito yung ibig sabihin nun. Pag sinabing level, triggered by level siya, siya ay parang discrete, no? Discrete yung kanyang signal. Ibig sabihin 0 and 1 lang siya or on and off, no? So ito yung 1 level niya, ito yung 0 level, yung mababa, no? So pag nag-level siya, ito lang i-consider niya na 1. Okay? So pag tumaas to ng 1, then the output or input will change, no? But sa pulse ay hindi yung taas, no? Yung pagtaas niya, yung event na tumataas siya at yung event na bumababa siya, yun ang trigger niya. Okay? So ito discrete, ibig sabihin 0 and 1. Ito may level, no? So habang tumataas yung pulse, nagbabago, nagtatagal yung output niya. It's either 0, 1, 0, 1, no? So ito naman yung pababa niya, magtatagal din siya, no? Kasi nakadepende siya dun sa level ng pulse. So yun ibig sabihin ng the different types of triggering the flip-flops. Okay? So ito yung ang application kasi ng digital device na to is makikita nyo sa yung mga bagong mga lighting ngayon sa bahay, no? Yung pwede mong yung may mga knob, pag pinaikot mo siya, medyo nagdidim, tapos magdidim hanggang sa dumilim, no? May level, no? So pag inikot mo siya, magliliwanag siya dahan-dahan, no? Meron siyang pwede mo baguhin yung kanyang dimness, no? Pero pag sa level, pag sinabing level control, para ito yung switch na walang ganong hindi advanced, no? Pag pinindot mo on siya, pag pinindot mo off siya. So it's either on and off lang, no, madilim or maliwanag. Pero sa pulse, kung digital yung device na nagko-control ng lights mo, ay pwede mong i-dim, no? Hindi maliwanag, hindi madilim. Okay? So ito rin yung device na ginagamit sa mga smart na mga component ngayon, no, yung mga smart na speaker, no? Kapag lumakas yung sounds mo na masyadong out of the required level, no, out of the maximum level, automatic ibababa na niya yung system kasi digital siya. So ito yung mga control, no. Sa computer naman, syempre siya yung nasa loob ng chips, no. So siya yung nagpa-process, no, ng mga kung ano yung lumalabas sa screen natin. Okay? So ito yung sinasabing pulse ng ayan, okay? So yung ating input output, yung output natin nako-control ng clock, no? Kapag tumaas siya, that is a positive pulse. Pag bumaba, that is a negative pulse. Okay? So it toggles, no, the state of the output. Next, we have the master slave flip-flop. The master slave flip-flop is constructed from two separate flip-flops, no? So master flip is enabled when the positive edge of the clock pulse is CP and the slave flip-flop is disabled by the inverter, no? Kapag 0 naman siya, then the master flip-flop is disabled and the slave flip-flop is enabled. So nire-reverse lang niya yung state ng master between master and slave flip-flop. Edge trigger. Yan, another type of flip-flop that synchronizes the state changes during a clock pulse transition is the edge trigger flip-flop. Okay? So when the clock pulse input exceeds the specific threshold, the inputs are locked out and the flip-flop is not affected by the further changes in the inputs until the clock pulse returns to 0 and another pulse occurs. Okay? So kaya yung nakakontrol yung volume ng ating mga devices or yung mga levels of electricity or electronic signals, no, because of this edge triggered flip-flop. Okay? Direct inputs, flip-flops in integrated circuit. Packages sometimes provide special inputs for clearing the flip-flops asynchronously. So, example nito is after the power is turned on the digital system, the states of the flip-flops are indeterminate, no? Ibig sabihin unstable. So, merong parts doon na pwede mong i-activate, no, yung parang reset or clear. So, Pag na-activate yun, mawala yung instability niya, no? And it will return to the zero state. Okay? So that's it for our sequential circuits, no? So we will go back with the topic for register, no?